Okay. Hey everybody, welcome back to this week's stream. Let me see, just get my windows set up here. Okay, so Sunday again, time for another stream, and we are still going over the home building process from start to finish. In the previous two parts to this, so this is going to be part 3. The previous two parts we covered, well, in part 1 we covered planning, excavation, foundation, and subslabs. Part 2 we covered framing, sheathing, dry-in, and roof. That was last week. So this week we're going to get through as much as we can for the rest of it. I think we probably will go through drywall and leave everything that comes after that, which I just throw all into the last phase finish work. We may do that next week. We'll see how much time we got left. Do let me know if you guys have any questions. Just type them into chat, and I do have that pulled up so I can see anybody's questions there as we go through this. Let's see. Let me pull up. Okay, so let's go ahead and jump right in. We're going to start off, well, let me cover, first we're doing rough-ins at this point, right? So up to now we've got our structure, the foundation done, we framed it, we sheathed it, it's dried in, it's ready to go out of the weather. You can do anything on the inside and it's going to stay nice and dry and protected. So at this point you start doing all your rough-ins, okay? If you don't have your roof on, you don't have your weather barrier on around the outside walls, you don't have windows in, then you probably don't want to move on to this phase just yet. You can kind of get started a little early depending on what it is and how much of the dry-in is finished. But yeah, that's pretty much, you need to get to that point so that everything that you're doing from this point forward needs to be protected on the inside, okay? And you can also start getting siding and stuff done around the outside if you want to. So as far as rough-ins go, I mentioned this previously, you're going to want to do your rough-ins in order from largest to smallest physically, right? What you're installing. Typically that's the order you want to go in. Doesn't always have to be, but ideally that's what you're aiming for. So the first one's going to be mechanical rough-in. This usually involves a lot of ducting, and then you're going to have your HVAC, ERVs, dehumidifiers, that sort of stuff, okay? Let's start with the simple stuff. Simple stuff, every single house is going to have some ducting of some sort, right? You're going to have dryer vent for sure. Every house has a dryer. You got to have washer dryer. So you're going to have dryer vent for your dryer. Something I'll say about that real quick, code does, check your local code, but typically code does require that you have hard vent for that. So there's like the hard metal ducting for vents, and then there's the flex duct, whatever you want to call it. It's like the, it's like foil with some insulation in there or whatever, and it flexes around or whatever. It's just got a wire, like a spiral wire that runs through it. So you have the foil wrapping the spiral wire, and then sometimes there's some insulation in there, sometimes not. You can get it either way, I believe. I really don't ever use flex duct for anything. Well, that's not true. I will use it for like vent fans, exhaust fans from bathrooms, but that's about it. For the dryer vent, typically you have to use a hard duct. So I just get the cheap metal ducting, right? And you can throw that in, try to do a straight run if you can, basically with one elbow is fine. So you're gonna come out of your dryer vent and you're gonna go up, let me pull up an example here so I can kind of demonstrate better than with my hands. Dryer vent ducting. So here's examples of what I was talking about with the different types. So you got like this flex duct stuff. That's an I haven't seen the black kind before, but and then you got your rigid ducting. This is kind of what I was talking about. You can buy this in like 3-4 foot pieces and just fit them together and extend it for as far as you need to. So this is the kind of thing where you're going to have the actual, so your dryer, this is in the wall right behind your dryer. Your dryer is going to connect straight into that. Okay. This is typically done with a little short piece of flex duct that comes with the dryer, or sometimes not, but that's okay. As long as from here to the exterior of the house is all hard duct, then you'll be fine. So from here, you're going to attach the hard duct inside the wall to the top of that, typically with something like this. You can also use things like this sometimes. And that's going to go through the walls, through the ceiling to the outside, and then you're going to have a vent cover on the outside where it goes out. So that's something I wanted to mention about that. I have inspected houses where they installed flex duct for the dryer vent. I see that more commonly with owner builders or first-time builders, but I've even seen it with some more advanced guys, more experienced guys. So make sure you're doing that correctly. Make sure you're following your code for your area. When it comes to your exhaust fans for bathrooms, that's going to be the second one that every house is going to have, basically. There are some rules around that where you don't necessarily have to have one if you've got enough venting via like windows and whatnot, I believe. I just always throw one in because they're extremely cheap and really nice to have, especially if you got a shower in there. So for those ones, you're going to have ducting going from the fan through the ceiling straight to the outside, vent cover on the outside where it exits. Not much else to say about that. That's pretty standard. There's different options for your exhaust fans. Go with whatever. Mostly the main difference, there's two main differences. The volume of air that it moves, like how quickly, right? How powerful of a fan it is, and then how loud it is, the noise level. I always like to try and go with really quiet fans, but I do like to be able to hear it. I'm not a big fan of fans that you can't hear at all, or like you have to have the room completely silent to listen for it, because I like to know if the fan is on or off. But I don't want it to be super loud either. But really making sure that it gives enough ventilation to that room is going to be key. Beyond those two items, you're going to have HVAC and heating. This is going to be part of your mechanical rough-in typically. And with that, you'll usually nowadays, with modern construction, you're going to want some sort of ERV as well if you're doing an airtight home, which building code is, the newer building code is already pretty much to airtight homes. And jurisdictions are now, as they adopt the newer codes, are moving into that. So it's just something to get used to. Everybody's going to have to start building that way at some point, basically. So yeah, ERV, just make it part of your standard mechanical package. That's pretty much what I do nowadays. Dehumidifier, if you're in a very humid area, that's probably a good idea. I build mostly in very dry, high elevation areas in the mountains, so it's not a big problem. But consider that if that's something that you think you'll need as well. As far as the HVAC and heating systems, there's different options there. You could go with a full, what's the word I'm looking for? You could go for a full system, right, with HVAC, everything. You could go with just heat. In my areas, that's common more on older homes. Nowadays, they all pretty much have like, I wouldn't say central air, but like mini splits or something. But on older homes, you might see just heat because it doesn't really get that hot here. And if it does, you just open a window, there's a nice breeze that blows through the house. It's not too bad. So, consider what your needs actually are, what you can get away with based on where your location is at, and then design your system based on that. Not a bad idea. I mean, you're going to be hiring professional anyways to install all this, get their opinions. You're going to want, I can't remember what's called off the top of my head. There's a schedule or design standard for mechanical systems. I'm by no means a mechanical expert. I pretty much just let the sub handle all that. It's one area, that and electrical are kind of the two areas I don't do a whole lot in myself. But yeah, that's something just to be aware of. They're going to design the system to match the house you have. So you need to give them a copy of your plans. They're going to work all that out, figure out what you need, placement, all that. Just make sure you're getting proper ducting is really a big thing that I see a lot of people miss on these newer homes that I inspect. So make sure you're getting that. Let's see, anything else I wanted to cover? I think that pretty much covers it for mechanical rough-in. There's not a whole lot to it. With all these rough-ins, I'll go ahead and mention now there are these things called nail plates. And this is something that gets missed a lot in inspections that I've done. I'll just look up the basic ones. So these are nail plates. These go on the framing of the walls, anywhere where you have something, a penetration, right, like a wire or a pipe or ducting or something that's going through the studs of that wall, and they're closer to the surface of that wall. Maybe I can find an image of it, actually. Code illustration. So, yeah, that's pretty good. So see here, you have these pipes going through the studs. Now there's a chance somebody's gonna come along and put a nail or a screw or something into the stud there. Once this is all sheetrocked or has drywall up on it, so you can't see the pipes there. Could even be the drywallers. They throw the sheet up on there, forget where those pipes are, and they just start throwing screws in. If they're using, you know, if this pipe was, in this case, probably wouldn't hit it. It's hard to tell in this picture what the distance is there. But basically anything within, I would say, 1.5 inches. I think code requires within, what was it, 3/4 of an inch or quarter, off the top of my head, I can't remember. They're pretty good at this. I think it's 1.25 inches. But I just always look for 1.5 inches. If it's 1.5 inches or less space, throw a nail plate on there. And that should give you, because you think about it, you got a 3.5-inch 2x there, right? If it's 2x4 framing. So you got inch on each side. Well, 1.5 inches on each side leaves you an inch right in the center for these pipes to go through. These pipes are 1/2-inch pipes, so that basically gives you double the diameter of the pipe for space to drill your holes through. So unless you're just terrible at centering your holes on the studs, or not you per se, but your builder, your framer, unless they're just, it's not even the framer, sorry, the plumber. Unless your plumber's just terrible at lining their holes up center on the stud, you know, it shouldn't be a problem getting pipes and everything, wiring for electrical, PEX for plumbing. The only things that you see, that I see these mostly on for these nail plates, is going to be your ducting for any mechanical, and then any of your drain pipes for your plumbing. A lot of times come really close to the edge of the stud, so you're going to need nail plates there. Now, these ones are fine. These are the smaller nail plates. Sorry, you couldn't see my mouse. These are the smaller nail plates here. There are bigger ones. So these ones are fine anywhere inside of a wall, right? But when you're at the top or bottom of a wall, oh, and if you have something interesting like this where you got a whole big gap you got to go through, you'll see some funny things with plates. Trying to see if I could find. So here's an illustration of what I wanted to talk about. Nowadays, there are these, can I make that bigger? Okay, whatever. You guys can see what I'm talking about though. So at your top and bottom plates, so at the bottom of the wall, anything that's going through your bottom plate, and then at the top of the wall, anything that's going through your double top plate, like in this illustration here, you're actually nowadays with current code, I believe since 2018, maybe even 2016, but I think since 2018 code or newer, you need to have these taller nail plates. And this is something that I've caught a lot of people on. So here's an example at the bottom plate, at the bottom of the wall, and then just they cut out the middle of the wall. But at the top of the wall where you have your double top plate, you gotta have that. And I believe, I'd have to go back and look again. I believe it says you have to go 2 inches above the plate for bottom plate, and then below the plate for the top plates. I don't remember specifically if it differentiates between the two off the top of my head. Basically now I just make sure everybody always has these bigger nail plates at top and bottom, and that will pass code. Trying to think if there's anything else with that that's important. Not really. So just make sure that you have them where you need them. Gas lines, again, make sure you have nail plates anywhere. That's a really important one. So yeah, that's pretty much all I want to say about that. So I think that pretty much covers our mechanical rough-in at this point. We can move on to our plumbing rough-in, which is going to be your next largest rough-in, right? So your drain pipe is the next biggest item that's going in the walls, and then you'll have your water lines. So let's take a look at DWV rough-in. So typically it's going to be called DWV. If you're talking to your plumber, he might call it DWV. If you're talking to your inspector, he might call it that. That just means drain, waste, vent. This is any pipe that's going to be part of your drain, waste, or vent system. Typically there's only two types of pipe that you'll see for this nowadays. It's going to be either PVC or ABS. Okay, PVC is the white pipe like you see in these images here. And then let's see, so here's a good example of kind of a tree of DWV here. So they've got obviously multiple fixtures going in here. That looks really big for a sink, but anyway, those are probably sinks, and then you got your clean outs, and then it connects to your vent that goes up through the roof, and then down to your drain, which goes under the slab here, and so on. ABS is another one that you'll see. That's not what I was looking for, not abs. ABS drain line. I guess I drain pipe. If I could get the okay, but anyways, you get the idea. ABS is this black pipe. This is going to be used usually sub slab. You'll see ABS used a lot. Sometimes the whole house will be plumbed with ABS. It just kind of depends on the plumber and what their preference is. But yeah, the only real difference between the two types, ABS has a lower, is it ABS or PVC? And forgive me, I'm not really a plumber, so I think it's ABS, and you guys can correct me if I'm wrong, but I believe ABS has the lower pressure rating. So this is not good for anything that's going to be under pressure, like water lines and stuff, but for a drain line, it works fine. PVC, the white pipe, has a much higher pressure. The glue, it's not really the material of the pipe itself, it's the glue that holds them together at the joints. The ABS glue just doesn't hold under as much pressure as the PVC glue. So that's why you'll see PVC definitely needs to be used if you're using it for anything that's going to be under pressure, such as water. But if you're using it as a drain line, ABS or PVC, both will work fine. Kind of just depends on what your plumber wants to use there. I do believe ABS holds up better though, in like soil and those sort of things. Not positive on that, but I think it does. Maybe a plumber could let me know. So those are kind of your two options for your plumbing rough-in. As far as your DWV, it's pretty simple, honestly. DWV rough-in looks complex. So wanted to show you kind of, I guess this illustration is a good example. So you'll have all of your drains wherever water needs to drain down, right? You'll have those from every fixture in the house, and then they all go gravity fed, drain down to under the slab or under your crawl space, whatever you got under your foundation, and then they'll drain out to either your sewer, septic, whatever it is that you have there. But it exits the house from underneath. You can, if you're not able to do gravity fed, you can put in a pump and extract it out vertically. That's an option. It's a little more expensive, obviously, because you got to purchase the pump. You got to put the pump inside the wall or whatever and get it out. I don't really do that because we're typically always building on a slope and it's easy to get things out. From there, you'll have pipe also going up through the house, up and out the roof. This is called your vent. This allows everything. So when your drains have stuff flowing through them, they need some way for air to escape. That's what the vents are for. So it allows the flow to continue down instead of getting clogged up. The vents will all come up usually into an attic space and then join together into one pipe and exit the roof. Maybe you might have a couple different vents exiting your roof, depending how big your house is. Really big houses will have sometimes 3-4 different plumbing vents exit through the roof. Small house, like a 1,200 square foot starter home, you're just going to be going typically with one vent, possibly two if you have plumbing at each end of the house and the plumber just doesn't want to connect them. Clean outs, you'll have clean outs at various spots, usually at least a couple in the home. And trying to think if there's any, I don't think there's much else to say about DWV there. With the plumbing rough-ins, I'll go ahead and say now with all the plumbing rough-ins, so this goes with your water lines, any gas lines, and this goes for your drain lines, DWV. This does not apply to radon vent, which I'll talk about in a minute. But everything else, as far as your plumbing rough-in, you have to get pressure tested, okay? The inspector is going to want to come in and inspect all this for your rough-in inspection, but he wants to see the plumbing under pressure, pressurized, right? To various, depending on what it is, when he comes to inspect, okay? Water line, well, DWV needs to be pressurized to 5 psi if you're using air, or you can just do 10 foot of water head pressure. That means you just cap everything. Well, you have to cap it either way, whether you're using air or water. But if you're going to use water to pressure test it, cap everything and then go up to the roof where the vent comes out of the roof, and you just put like 10 feet of pipe up there, fill it with water. The whole system, it'll fill with water all the way up until it comes up to the pipe sticking out of the roof. And then you leave it there. The inspector will walk through the house and make sure there's nothing leaking, and then you're good to go. If you're pressurized with air, you just use a compressor, pump it up to 5 psi, is what code requires, IRC code, and you're good to go there. Water lines. Well, no, let's do gas lines next. Is your next highest pressure? Okay, so your gas lines need to be pressurized to 15 psi by IRC code. And with all these, check with your local code, your local inspector. Make sure that they're running the same. But that's typically what you'll see. So 15 psi for your gas lines, 5 psi for your DWV. And then your next one is going to be your water lines. Water lines need to be, well, for us, pressurized to 50 psi. That's typically what your water pressure coming into the home is going to be at for most areas. Anywhere between 50 and 100 psi, I guess, is pretty typical. So really, but as long, I believe code only requires 50. It's 50 or 60? 50. Code requires 50 psi. It just needs to hold that for 15 minutes at least while the inspector is there. As long as your pressure doesn't drop while the inspector is there watching it for 15 minutes, then you're good to go, right? If you leave it there for 2 days and you notice that the pressure dropped a little bit on the second or third day, that's probably going to happen. That can happen for a few different reasons. Usually it has to do with temperature changes. Okay, that'll alter your pressure in there. But basically, get everything pressurized for when the inspector comes to do the inspection. Now, the last thing that you're going to have, well, no. So let's talk about gas lines and water lines. Gas lines, you're going to have them coming in the house at some point. A lot of times you're going to use copper for gas lines. There are other options. There's flexible tubing and all that. So just make sure you get it pressure tested. That's going to be the key to the gas line. That's really the only thing that matters. You're just taking it very simply from wherever the gas comes into the house and then take it to wherever you need it. If it's a gas appliance in the kitchen, you're just taking a pipe there, and then maybe one to the exterior of the home, wherever your porch or deck is, if you want to put a grill or something out there, right? What else? Maybe if you're using gas water heater, make sure you have gas line going to your water heater. If you need gas for your heating, make sure you have gas line going to your heating system. But other than that, that's pretty much it. It's really possible to build a house with no gas at all. And if you're trying to go for, low cost, cost efficient build, I recommend not doing any gas. I know people like to have a gas cooktop in their kitchen, and that is a big selling point for a home. So keep that in mind. If you're doing kind of like the mid-range or up as far as the home that you're building. But if you're doing lower range, starter homes and whatnot, just don't even bother with the gas. You can stub it, but just leave it electric, and that tends to work out okay. At least in my area. And it does really depend on your area, what's common in your area, what's not. If you're in a city, it's really easy to get gas in the house. Where I am in county, we have to have a propane tank to get gas to the home, right? The city doesn't have gas lines. So it's actually not that uncommon to have homes around here that don't have any gas in them because people just don't want to have the propane tank there. On the topic of propane tanks, if you are doing propane tank, there's two different options. You could do a buried tank or above ground tank. If it's above ground, just make sure you got proper clearance from the home and from lot boundaries. In our area, that's going to be 10 foot. You got to be 10 foot away from the home, 10 foot away from lot boundaries, which is the setback. It's the same thing as a 10-foot setback. If you could put it further away, probably a good idea, but just remember you do have to bring the gas lines to the house from it. So the further away you get, the more expensive that gets. Although it's really not going to be that much incrementally. Buried propane tanks are nice. You don't have to see it. Just make sure you have easy access for them to be filled. Other than that, radon, I was going to talk about water lines. So water lines nowadays, it used to mostly be done with copper. Then they came out with this like gray flexible pipe that was called, what was it called? Polybutylene. I think that's what it is. Polybutylene pipe. It's like this. It looks like PEX, but it's like a solid gray color. Almost looks like rubber, right? That stuff was crap. They used it for, I think in the 90s, like late 90s, maybe up to early 2000s. It was used pretty commonly because it was a new material at that time. And then about within the first 10 years of using it, they realized it would fail. But within 15 to 20 years, 10 to 20 years, really, they started to see failures around 10 years. And then as the time went on, they noticed that there was more and more failures up to about 15, 20 years, I believe. My house that I live in now actually was built in the mid 90s. When I bought it, I completely took all the water lines out, stripped them all out, and put PEX in because it was all polybutylene pipe. And there were some failures. The house had a history of failures with the water lines. So I tore like everything out and redid the house, a lot of it from studs up. So that was a fun project. But yeah, polybutylene crap. If you see that in a home, replace the whole system. Just get a guy, do what you have to. You have to tear open all the walls, ceilings, that kind of stuff, and do all the drywall repair at the end. But get all the lines replaced. Fortunately, those lines can usually be pulled through the walls pretty easily, so it doesn't require opening up quite everything. But anyways, if you can, you want to replace it with PEX. PEX is what we use nowadays. It's the modern material for water lines. It's extremely fast and easy to install. I do PEX lines. I am no plumber by any means, and I don't like doing plumbing, but I'll do water lines with PEX all day, every day. It's extremely easy to install, quick, and doing it yourself can save you some money because plumbers are still going to charge you a lot, right? They have their hourly rate for things. It is fast, so it's not going to, it doesn't rack up quickly because they are able to get a lot of the work done quickly. But they're still going to be charging you their $100 an hour or whatever they charge, depending on your area. So if you do, that's something you could do yourself. Let's say to you, it's only worth 50 or $60 an hour. You can either find some basic labor and just supervise it, make sure they know what they're doing, or go in there, do it yourself. I've done it myself a lot just to save some money. I mean, I'd rather pay myself, right, than pay a plumber to do something that simple. So with PEX lines, make sure you're using the right kind of PEX. There's PEX A, PEX B. I prefer PEX B. I believe it's PEX B, if I'm remembering correctly. PEX A is it's the expansion fitting, so you have to use a little thing to expand. Actually, let's look it up, huh? PEX A. I don't know. Let's just see what that comes up with. Yeah, so it's going to be like one of these things. So PEX A, you have to use one of these expansion guns. It expands the end of the pipe so you can fit the coupling or whatever into it. Or you can also put these little bands on the outside, I guess. I haven't really ever used PEX A. I always use PEX B. But this is what PEX A looks like. You basically need the expansion tool. You expand it, fit it together, and then it compresses back onto itself. I prefer PEX B. I feel like it works better and it's easier to do. The tools aren't expensive. This little expansion gun can run you, $100 or whatever. Or you can do this PEX B method with these little, it's a crimper, right? So you're crimping these bands on the outside and that's what seals it onto the fittings. The tools that do these are just little like pliers basically, right? So they're like $20. Cheap tools, gets the job done, very simple. I've never had any problems with it. As long as you remember to do these and you're tightening it down all the way with the crimper, never had a leak. You can use different kinds of fittings. There's brass fittings, there's plastic fittings. I actually usually use the plastic fittings. They work just as good as the brass. I don't see really any reason not to use the plastic in my experience. I know there's guys that will say otherwise. Personal preference. The brass is obviously going to be a little more expensive. Although you should be able to get by, if you're doing PEX B, you should be able to bend most of these angles in the walls without having to use any of the fittings. If you can get away with using no fittings with PEX, that's the best way to do it. Because every time you're using one of these fittings, the inner diameter on these fittings is less than the actual inner diameter of the pipe itself, the PEX pipe. So every time water flows through those fittings, it's being restricted a little bit, right? So that's important. I believe there's other ways to do it where you can get like oversized fittings and there's something like that. I usually just bend it through. You can do 90-degree bends with PEX fairly easily. They make these little clip things that help you, like little plastic clips that you can fit the PEX into and it'll guide it into that 90-degree turn. I use those a lot. Another thing that I want to mention with PEX is, oops, I'm on the wrong screen here, is this manifold system. So this is called a manifold. So PEX can be run into the home in two different ways. You can have what's called a tree and branch. I think that's what's called tree and branch system, where you have one, it's like a traditional water line system, where you have one main line and then branches off that main line to each fixture throughout the home. That's the cheaper way to do it. Uses a lot less material and it's a lot faster to put in, right? If you're going budget, just do that. If you want something a little bit nicer, and gives the homeowner more control over their water system, do a manifold. So the manifold has your water coming in, that blue line is your cold water coming into the home, comes into the manifold, and then you have every single fixture throughout the house is on a separate branch. Every one of these branches can be turned on or off with this key. So that if you have something that's leaking, you don't have to shut off water for the whole house. You just shut off that one branch that's going to that fixture. Really nice system. I've used this in my own house when I did the PEX in my house. I've installed these, or I've worked on these in other homes. I haven't installed them, but I've seen them in other homes a lot, and they are actually a really nice system. Most people I know that have had them won't ever go to anything else. So it's like having a circuit breaker for your plumbing, which anyways, and then you have your hot water coming in from your water heater as well. And that goes all to all your hot fixtures. And then it's all labeled, of course. Really nice system. Just it does cost more. It's obviously more labor intensive, going to use up more material in the PEX pipe, which isn't super expensive anyways. You might have a couple $100 worth of extra pipe there for a typical home. The manifold itself costs like $250, $300, I think, last time I bought one. Depends on how big of one you're getting. They have different sizes, so if you only need a small one for maybe an ADU, that's fine. If you're going for like a big 4,000 square foot home, you can obviously use multiple manifolds, I guess would be a possibility, or you can also buy, I think the biggest one, well, I don't want to say because I'm not sure, but they make some pretty big ones. Look into that if that's something that you're going to need. Plumbing going to the exterior, you're going to have any water lines that go to exterior faucets or spigots, anything like that, right? Obviously, you're going to want to make sure you have proper, in my area, we use frost protected silcox for all of our exterior water hose connections. So what that means is that it just has an extended, in our case, they're like 12 inches, I believe. That extends all the way into the wall, and that's where it shuts off the water on the inside of the wall, rather than right on the outside where you're turning the thing. That way the water is not freezing in there and causing big headaches for you. So make sure if you're in an area that gets below freezing at some point in the year, use those. Otherwise you're fine just probably using whatever. Your plumber will know what to use though. One thing I want to mention about that, nowadays, something I like to do is, at least in my area, because we get really cold here for about half the year, I like to have hot water also to the outside of the home somewhere, usually just one spot over near the garage area. I'll put a hot and a cold spigot on the outside. What else? There's some pretty fancy new stuff. Aquor does these, like, it looks like an outlet from the outside until you open it, and then you plug the hose into it, and that's how you get your water. It's really slick looking design if you're going for something modern and sleek. It's a little more money, so I don't know if it's really worth it. I typically would not use them unless you're doing something high end. What else? I think for water lines, that's pretty much going to cover it. Let's see, Jacob. Another thing I would always keep in mind for contractors wanting installation requirements of mechanical systems is to use install manuals to see code requirements. Yes. Install manuals are great. I always keep all of them. I got a box full of a whole bunch of different ones I've collected over the years. Always read the manuals. I know it's, and a lot of times as a GC, you're going to expect your sub either knows how to install or they're going to learn how to install it because that's their job, right? Don't count on that. A lot of time, I've seen it time and time again. A guy will go in there, he'll get something that he hasn't installed before, so it's a little bit different than maybe what he's done in the past, and he just wings it, right? He figures, well, it doesn't look that hard, I'll just install what looks correct. And sometimes they'll miss a key detail of the installation. So like Jacob was saying, great tip, always yourself go and read through the instruction manual for everything that you're installing there. Make sure that you understand what the proper installation is going to look like, because you're responsible for, the inspector isn't going to know specifically what manufacturer installs and directions are for something, right? If it's something they see a lot, they probably will. But I mean, I see things all the time that I haven't seen before. I have no idea what the proper installation is. I make sure code is met, and then beyond that, you know, it may be just on the builder. That's one of those builder warranty things. That's why builders provide warranties. If they don't install something correctly, they're coming back and fixing it. The inspector's job is not to catch every single mistake that the builder makes. The inspector's job is to make sure that that home is safe and habitable. Okay, that everything is up to code. So you as a GC, as the builder, you need to be aware of these things. You need to know what the proper way for that to go in is. And it's really easy to find out. Nowadays, you can usually find a YouTube video from manufacturers themselves that show proper installation. If there's nothing on YouTube or a video showing you, they always have their literature on their websites. So if the builder, or I'm not your builder, if your sub threw away the manual or whatever, or it got tossed out by accident somehow, you can always go to the manufacturer website and download their instructions there as well. I like to get digital copies so I can just pull it up on my phone anyways. It's a lot easier than lugging around a whole bunch of hard copy manuals. Great tip there. Trying to think if there was anything else I want to cover with water lines. Sometimes, especially in higher end homes, you'll still see people do a lot of copper water lines. Radiant heat is another thing I want to mention. This, I don't know if that's exactly what this is, but it's typically what a radiant heat system would look like. Here's another manifold example. That's a bigger manifold. This one, they did a whole bunch of elbows though on every single line. I would not do that. I would do it this way, where you're bending all those lines up, because then you're not, like I was talking about before, you're not restricting it with that fitting. Yeah, sometimes it'll just be in the middle of wall like that, or you might have it up against a wall like in the basement like that. Sometimes I've seen guys just sheet the whole thing with plywood on the back because they like having the nice solid backer there. Yeah, so another thing popular these days, especially in colder climates, radiant heat plumbing. This is going to go underneath your slab, and this just runs hot water under or through your slab, your concrete, which heats that up, which in turn heats up your home on the inside. Pretty fancy system, works really well, actually. The first time I ever heard about it, I was thinking, well, that can't work that well, could it? It really does, actually, and it's quite nice to have. It is going to be a little bit more expensive, obviously, both to install, you have extra cost there, and then also just to run it in your home it's gonna use more energy, water, that kind of stuff, right? But a pretty nice system. You'll basically see it, it'll be set up like this. A lot of times they do copper for the manifold, and then they'll, off the manifold, they'll run the PEX lines into the slab through these sleeves where it enters the slab right here. That's pretty standard. That's a pretty standard setup from what I've seen. Kind of like this. So you can see it comes down into the slab, and then it'll enter the lines as they go throughout. And it basically just circulates hot water through there whenever you need to heat things up. So pretty good system. You'll also see this used a lot in bathrooms, under bathroom floors, just because in the winter, you know, it's nice to have a warm floor to step out onto when you're getting out of the shower or whatever. So a lot of people like to do that. Here's another example of what it looks like before you pour the slab. So something to consider if you're in a colder climate for sure, and also if you're doing a higher end home. Let's see. For PEX, the big difference between A and B is tools, but also PEX A does maintain a larger inside diameter since it is expanded over the fittings. Milwaukee makes an inexpensive expansion tool. Yeah, yep. Basically the tools, the process for installing it is the big difference. I had not thought about the inside diameter thing. That's a good point. It would have bigger inside diameter, I guess. And then Milwaukee, I think they came out with that more recently, maybe. I don't know. I can't remember if I looked at that one when I was looking at the tools and everything in the past. It was years ago when I bought my tools. But yeah, you know, I'm sure it's pretty inexpensive either way nowadays. So, trying to think if there's any real reason why I would use one over the other. Not really. It pretty much just comes down to which tools you have is the only thing. That just make sure when you're ordering the correct one. If you're ordering yourself, typically though, if you're hiring a plumber, they'll handle all that. So you don't even have to worry about it. Just be aware there is a difference. Okay. I think that pretty much covers it for water lines. Let me know if you have questions on that. The last thing with plumbing rough-in that I wanted to go over is going to be your radon vent. So let's pull up an example of that real quick. I think I showed it before when we were talking about our sub slabs, but I'll show it again here because it is relevant. When you're getting your plumbing rough-ins done, this is the point at which your plumber is going to finish the radon vent through the house. So you got your radon vent when you did your sub slabs. If you remember, we had the radon vent was piped up, or it was just stubbed up through the concrete slab. If you're doing crawl space foundation, then you can do basically all of this at this point, as long as you have access to the gravel below the vapor barrier in your crawl space. So basically what you're gonna do is bury a plumbing T, right? A T fitting under that slab. I think it's 4-inch PVC. And then you're just gonna bring that up. Anything that's under the slab, so you can do a full perimeter of, you can take off of that T fitting, you can take perforated pipe, also called drain tile, and you can bring that around the entire perimeter of your foundation on the inside. That drain tile or the perforated pipe will allow the radon gas to seep into it. This is all done inside in the gravel that's under your vapor barrier, under your slab. Right. So the radon gas can then get into that pipe. It'll go up through that plumbing T, the T fitting there. And then your vent pipe is going to be solid PVC, not perforated. And this is going to go straight up through the walls of your home into the attic space and vent out through the roof. Pretty straightforward. There's not much else to it than that. If you do need an active system, I mentioned this before, but it'll be something kind of like this is how you retrofit a house with an active system. You would break a hole in the concrete, fit that. This doesn't have the plumbing T there, so this is not 100% accurate in this image. They do need some sort of fitting there at the end of that. But yeah, they'll bring the pipe up, exit the house through the rim joist. They'll put a fan on the outside of the house. That's what's inside that little bulb there is a fan. You can see it has the electrical connection there. And then that fan will continue to push the radon gas up. It'll suck it up out of the bottom and then push it up through the vent all the way up and out up top. This is kind of, oh, I'm on the wrong screen here. This is an illustration of the same thing, but you can see it, then it vents all the way up and out. So pretty simple. Radon gas, leading cause of lung cancer, I believe is what I'm told, after, other than smoking cigarettes, I believe. So something definitely be aware of if it's an issue in your area. Make sure your vent is hooked up correctly so that you're not having leakage into the house. Pretty simple. I think that's all I'll mention. Oh, one other thing with your radon vent, make sure at each floor of the home it's labeled. Usually this is just done because it's white PVC pipe. You can just take a Sharpie, a big fat Sharpie, and write radon on the pipe at each level of the home. So basement or crawl space, main level, upstairs, attic, label it at each level. That way in the future, anybody that does any work on that plumbing system knows that that is not a DWV line. It is radon vent. It's pretty much it. Where it vents out the roof, it just needs to vent near the ridge of the roof. Make sure it's not near any windows. If you have dormers on your roof or something with some windows that can be opened, you definitely don't want to put it near those. There's code specifies distance for all that, so if you need to, look that up. I think that pretty much covers everything for the radon gas. That's a fairly new thing. So people that built 30 years ago had no idea what this was, right? This wasn't even a thing 30 years ago. It's more recently that radon gas has become a known issue with homes, and is being actively mitigated. So if you built homes a long time ago, or you're working with somebody that built a long time ago and they're advising you, just make sure you're following current code for your radon gas. That is something I've seen people make mistakes with, or just not even know that they needed when I go to do phase inspections on new construction. Yep, I think that'll pretty much cover it for the radon. So that's all of our plumbing rough-ins. Again, you're going to need nail plates on all of your plumbing. That comes within, I think it's actually 1.25 inches, but I always just go 1.5 inches to be safe, right? Yeah, make sure you have your proper nail plates in. I think that's it. So like I said, you're going to need pressure testing on all this plumbing when you get it inspected. One more time, that pressures are going to be 5 psi on your DWV, 15 psi on your gas line, and 50 psi on your water lines. Those are typical. Your area might be a little bit different, so make sure you know what those values are for your specific area. But those are the typical code required pressure test values. Those values will need to be held under pressure for 15 minutes at least without losing any pressure, and you should be good to go. Make sure you get good pressure tests. That's really the way to know that your plumbing is solid. Sorry about that. That's really the way to know that your plumbing is solid, is by getting the pressure test once it's all installed. If it tests good under pressure, then you know you're okay to go ahead and cover it up. Typically. Let's hope so. So moving on from plumbing rough-in, we're now going to get into the electrical rough-in. This is the last of our rough-ins, and it's going to be the smallest. You're just wiring the whole home. You're going to put your boxes in and run wire from your boxes to your panel, for each circuit. Pretty simple. I'm no electrician, so I'm not going to go into a whole lot of depth with the electrical, because I don't want to accidentally give some bad information or something. Trying to think if there's anything in particular I want to mention about that. So you'll have your panel. That's where you bring the power into the home, and then it's going to send the power out to all the different circuits in the home from the panel. The panel has your breaker switches. If you ever need to flip the switch and shut off a circuit, that's where you do it. So make sure it's accessible. What else do I want to say about that? The fixture boxes, not really anything special about that. I think everybody knows what the fixture boxes look like. Well, I should say the receptacle boxes. Fixture boxes too, for like ceiling fans, lights, all those kind of things. You'll have the round fixture boxes for that. In fact, I guess I'll pull up examples here. So we'll have, oops, thought I was hitting backspace. I can't see my keyboard here. Let's see. So you'll have, let's do fixtures first. I can't see. See, so you got the round kind. These will either go in your ceiling or on the wall, like where you're doing sconce lighting or something like that. Vanity lighting, all that. Otherwise, you'll have them in the ceiling, maybe for a ceiling fan. I don't really use them in the ceiling for lights because I tend to just use the puck lights now, like the LED camless lights, and you don't need anything for those. So I don't really, but back in the day, it was pretty common to have these metal ones set up for things on the ceiling. And then you'll also have, let's go back up here. Receptacle boxes are the square ones. Obviously, you'll have singles, double gang, triple gang, all the different sizes, right? Depending on what your needs are. The metal ones or plastic, both are fine. Plastic is good for residential. The metal is good for commercial and residential. So if you're doing a commercial application, I believe you typically always need the metal ones. I don't really do commercial inspections, so don't quote me on that. I really just do residential, and we're fine with the plastic for residential. So, yeah, pretty straightforward. Wiring nowadays comes in all different colors. They changed that, I think, recently, within the last year? Wow, I can't type today. New electrical wiring colors. Let's just look that up real quick. I think there's a good chart. Oh, I know why. Electrical. Oh, what's it called? My mind just went blank. Keep thinking coax. That's not what I want to say. What is that wiring called? I always just call it wiring. No, I say it all the time, and now my mind is going blank. What is... because it's not the actual name of it, but it's what everybody calls it. Romex. That's what I was trying to think of. So Romex. I just couldn't get coax out of my head, so that's all I could think of. Okay, Romex colors. Yeah, so now you got these kind of funky new colors. It used to be wiring was all just white or yellow. Okay, so white was usually your 12 or your 14-2 wire, and then yellow was your 12-2 or 12-3, 14-3, whatever. Your 14 gauge was your white, 12 gauge was your yellow, and that's all you really need to know. Nowadays they've got different colors for everything. I think you still have white is your 14-2, yellow is your 12-2, and then I believe the blue is your 14-3, the purple is your 12-3, and so on. I don't know. Each color is for something different now. So now when you see a new construction home all wired up, it's really colorful. You got like the whole freaking rainbow in there. Where, well, it's not all color. I mean, there are other colors though, right? If you're running a bunch of different types of wiring. If it's a real simple wiring job on a simple little home, you're still going to have mostly white, yellow, and then a little bit of the blue and the purple for anywhere where you need those. Yeah, other than that, it's pretty much, I guess 10 gauge is the orange, I think, and whatever. I don't think there's much else I need to say about that. Again, electricians know what they're doing. Hire a good electrician. They do cost a lot, okay? I know electricians are expensive, but the good ones are worth what they charge. Believe me, it just is worth it. You don't want headaches when it comes to electrical. Yeah, not much else to say about that. So, one thing to make sure you're getting when the whole house gets roughed in for electrical, something I have seen people forget, right? Some builders have forgotten this. Make sure you have your smoke detector wiring in all the locations necessary. If you have a finished off attic space, right? Or check your code. The code identifies all the areas where you need these, but these are examples of areas where I've seen people miss it before, where we required it. You had like an attic space that was finished off for storage or whatever. They didn't have one there. They had a light switch right there, so it was easy to I think, well, they may not have had the right, because it has to be a separate circuit. So anyways, the thing with the smoke detectors, they all have to be on their own circuit, right? One circuit for smoke detectors, but it has to be a dedicated circuit for smoke detectors. They all need to be hardwired in, at least typically by code they need to be. There are exceptions for wireless transmitter type smoke detectors. So if you have to use, they're really for retrofit situations. But if you have to use something like that, make sure you're following both manufacturer install directions as well as code. I believe code requires that you have at least one of the wireless ones on the network of wireless ones has to be hardwired in, if I remember right. Something like that. I don't see it very often, if ever. I think I've seen it once. And it was a long time ago. But if somebody does forget one and it's just too expensive to bring the hardwire there are options for using a wireless smoke detector. But it's really easy to do if you make sure you got them all while the walls are still open and you're doing your rough-ins. So when your electrician is done, just do a quick walkthrough of the home. Make sure you have those in all the proper locations. Make sure you have switches in the proper locations. For example, stairway lighting, you got to have a switch at both the top and the bottom of the stairs for that. Okay. Any lights any room that has multiple entry points, you need to have light switches for that room at each entry point. Okay, so that's where you're gonna have like your three-way switches and all that. That's about it. Pretty important just to make sure you have the right stuff there. So when your electrician's done, do that walkthrough and look for those items. I think that's it for electrical. So let's move on. Insulation is next. So you got all your rough-ins done. You did your rough-in inspections. They all passed inspections. You got your mechanical, plumbing, and your electrical all good to go. So now it's time to cover it all up. You're going to come in and do your insulation first. So you're going to make sure you get insulation in all your exterior walls. You can also do interior walls if you want for some soundproofing. You can do your floors, ceilings. Ceilings in between floors, right? Or you can do that. That's optional, again, for soundproofing. or for zoned climate control. If you're doing separate zones for climate control in the house, having that floor insulation between floors of the home helps a lot with that, the efficiency of that. So keep that in mind. I mentioned the exterior. So floor, if you're doing like a crawl space, you definitely want to make sure you have proper R value insulation for your floor. Or the crawl space itself. If it's a conditioned crawl space, that means you're going to be insulating both the floor and the walls. I guess you don't necessarily have to do the floor, but if you're doing a conditioned crawl space, just go ahead and do the floor too. Why not? Just lay down some foam board, 2 inches of foam board at a minimum, and you're good to go. And it doesn't even cost that much to do. So if you're doing a crawl space, and conditioned crawl space, a lot of times I see it with spray foam on the walls. It's not going to be vented. Otherwise, if it's not a conditioned crawl space, you're going to have vented crawl space. So that means cold air can get in there very easily. You don't want that cold air getting up into the home. So make sure you have proper insulation all through the crawl space, the floor, right? That's above the crawl space. And then your lid, you're going to have what's called the lid, which is your roof insulation or attic, the fluffy stuff in the attic, right? A lot of times if you have an attic, this is going to be just blown in insulation. It's that fluffy stuff that's up in the attic all over the floor, right between the floor joists, or between the bottom cords of the trusses for your attic. Blown in is the cheapest option, honestly, for doing lid insulation. But if you're doing like cathedral ceilings, or if you're doing vaulted ceilings, anything like that, it's going to be a little bit tougher to do. So you may end up going to something like bats in those situations. Bats are fine. I like doing a flash and bat system because I tend to do a cold roof system, which is where you're actually moving the roof material off of the roofing deck using, I don't know what you actually call them, battens or furring strips or whatever underneath. Like, so if I do metal roofs, under that metal I'll have furring strips that are on top of the roof deck, just 1x material, so 3/4 inch, and it'll hold that roof metal 3/4 of an inch off of that roof deck, and that keeps the roof deck a lot colder than if that metal's sitting right against it, right? Because that metal's going to get really hot from the sun. So if the hot metal is sitting right against that roof deck, then the roof deck gets really hot, and that can create some issues if you're doing certain types of insulation inside of the roof system. So one of those systems would be a flash and bat system. Flash and bat just means you're spraying spray foam, usually about 3 inches thick, inside each of the cavities in that roof system. And then actually I can pull up a picture here. It'll probably be easier for you guys to see what I'm talking about. Yeah, basically like that. Is there a really good image here that we can look at? You can do it. So, okay, that is flash and bat. Looks like spray foam in the picture though. It's really hard to tell. Here's a good illustration though. So we'll use the illustration. Let's say you got the vaulted ceiling on the inside, right? What you'll do, you can just do all spray foam. That's fine. You could just do all bats or blown in, whatever, right? What I like to do, because I'm doing a cold roof system, you want to have the bottom of that roof deck sealed, so that air sealed, so that you don't have any moisture accumulating on the bottom of that roof deck, because it is going to be cold, obviously. That's why typically with a roof system, you're going to have vents. And I guess I should have talked about that first. What is typically done is you would have roof or bats inside there that would let airflow. Here's a good example. So air flows in at the soffit, travels up under the roof deck, that sheathing that's on your roof, right? That's called the roof deck. So you want airflow underneath that. This is a typical standard build. Imagine you don't have insulation here. Imagine this is just an attic. So you'll have your insulation down here at the bottom of the attic floor. All this would just be open. So you'll have airflow through the soffit, underneath that roof deck, all the way up to the ridge vent, and it'll come out the ridge vent. When you're doing a cold roof system, this all gets sealed up for air tightness. You're not going to have any venting through your soffits, and you're not going to have a ridge vent, and so you're not going to have any airflow under there. So instead what you do is you spray your foam right up against the bottom of that roof deck. That air seals the entire bottom of that roof deck, and then you can put your fluffy stuff, whatever you want, for insulation under that. You can do bats, you can do blown in, right, cellulose, whatever. Trying to think if there's anything else I want to say about that. It makes sure it's being designed properly. And if you're not familiar with how to do that, talk to your engineer. Engineers are great resources for these sort of things where you don't know exactly what you're doing. You know what you want, you just don't know the proper way to apply it to your build. Or if you're concerned that maybe you need something like this for a certain section of the house where you're doing a vaulted ceiling, maybe in the great room or the master room, right? Ask the engineer, is this necessary? Do you think I need this? What's the best way for us to do it in this case? So that's something to think about. Are there requirements for vapor barrier in ceilings? Typically, no. Vapor barrier, so this is why it depends on what system you're using. The reason I say typically no is because the typical roof system that you're going to use with insulation would be the one that I was talking about, where you have the air venting up into the attic. It's a vented attic, right? So you have venting coming up through the soffits and then out through the roof vent. That airflow through the attic is going to take care of any vapor. It's going to just push it all out through the vents. If you're not doing a vented attic and you're doing a cold roof system with a sealed attic, a conditioned attic, anything like that, or you don't have any attic space, you're just doing rafters that have the insulation packed inside them for a vaulted or cathedral style ceiling, then you're going to have to get a little more fancy. And there are ways to control the vapor even entering that roof cavity to begin with, such as using a smart vapor retarder. Which is basically a vapor barrier, but it does allow vapor to travel through it in one direction, depending on the temperature specifics and that sort of thing. I would recommend doing something like that, even with a flash and bat system on a roof. Ideally, that would be the best way to do it, because then you're controlling the vapor on both sides of that roof assembly. I don't believe, in most cases, at least I haven't heard of it, I don't think there's usually issues with vapor doing the flash and bat system, because you're completely sealing the bottom of that roof deck. The inside of that spray foam, as long as you're doing enough of it, and this is where make sure for your area you know how much of that spray foam you need. Typically it's going to be like 3 inches. Okay, so if you do 3 inches of the closed cell spray foam, not open cell, closed cell, 3 inches of that spray foam on the inside there, and then you just do bats or blown in, whatever you want, for the rest to get your R value there for the lid. You don't, the vapor, even that the vapor that does get inside that roof cavity, it's gonna hit that closed cell spray foam and not go any further. Well, the inside of that closed cell spray foam is still going to be warm. Okay, so you're not gonna have condensation there, so you don't really have to worry too much about the vapor if it's all done correctly. The only time the vapor really becomes an issue is when you have air leaks, cold air somehow manages to find a way into the roof cavity there. That's going to cause problems for you. So it is still a good idea to use some sort of vapor retarder on the ceiling before you drywall. And that's going to stop any vapor from getting up into that roof cavity to begin with. But then even if it does, as long as you're doing something like a flash and bat system, you still hopefully won't have any issues. I don't want to say 100%, but it's fairly uncommon as long as the installation is all done correctly and you completely seal the bottom of that roof deck with the spray foam. I think that's about it. I don't know if there's much else I want to say about that right now. As far as insulating the roof, do make sure. So I mentioned open cell versus closed cell spray foam. There are some major differences between the two. Okay. I know I've heard of some insulation companies that will really push the open cell. I don't like open cell. It's basically a sponge, if you ask me. At least closed cell, and I've seen the tests done, closed cell spray foam does repel water fairly well. Not if it's submerged in water, but if you have a small leak and water's just dripping down something, that closed cell spray foam isn't going to soak it up like a sponge. It's just going to repel it. The water is going to continue to drain down and out somewhere, right? Assuming it has somewhere to go. If it has nowhere to go, that closed cell spray foam essentially stops the leak. Now, as long as there's not going to be like a pool of water sitting in that spray foam, it should be fine, right? The closed cell should be fine. Open cell, it's going to soak it up like a sponge and you're going to have water sitting in there for years. That's why I don't like using open cell. Also, open cell gives you less R value per inch. So you have to have thicker, more foam to get the same R value. So I do really prefer the closed cell. Closed cell is a harder, like if you touch it, it's a lot stiffer and harder. Open cell, you can poke your fingers into it really easily. That's the easiest way to tell which kind of spray foam it is. When the guys come in and install it, and if it looks a little off to you and you're like, did they install the right one, just go up and touch it. If you can easily press your fingers into it and they poke a hole right into it, then that's open cell. If it's tough and you really have to jam your finger into it to even penetrate the outer layer of that foam, then that's probably closed cell. But yeah, as far as I guess the only other thing I'd talk about as far as your lid installation is going to be R values. Make sure you're getting the proper R value that you want. Don't always just go with what's required, okay? I think I mentioned this before in one of the other live streams, but I'll talk about it again. In my area, we're still on 2018 IRC. Okay, back in 2018 for my climate zone, which is climate zone 7, 6 or 7? 7, I believe. We're in the Rocky Mountains, high elevation, very cold climate. I think the only other areas in the country that are the same climate zone are areas that are near the Canadian border, right? Like north, or no, what is it? I don't know. Maybe it was North Dakota. Montana, North Dakota, areas like that. But basically, the code back then, or the consensus back then, was that for our climate zone, you only needed R49 for your lid, for your ceiling or roof, whatever you want to call it. So that's what code currently, our local ordinances still call for R49 on new construction for the lid. Current code, though, current standards, I should say, based on climate zones, for our climate zone, we should be at R60 now. Okay, and that the last probably 10 years of updates to the IRC code have been very focused on efficiency. Okay, so a lot of the changes, not all of them, but a lot of the changes that have been made to IRC code over the last 6, 8, 10 years have been efficiency based. So they're trying to get higher efficiency homes so that we're using less energy. That's just one of those things. Upping the R value requirements for the lid from R49 to R60 just increases the efficiency of the home. I guess they did studies. They figured that it was a big enough gain in efficiency to make it worth it to require it. Okay, that's apparently how it went. So even though it's not required for R49, or only R49 is required in my area still for new construction, if it's in my budget, and if I have enough space for the installation physically, right? If I'm doing cathedral ceilings and I only got a 12-inch rafter there, it's going to be kind of hard to fit R60 in there unless you're going full spray foam. So that's an example of where you might be limited on that. But if I can, I like to go full R60. Okay, just get to the current code, even if it's not required in your area. It probably will be at some point down the road, so you might as well get used to building that way now, unless it's just a big budget restraint for you. I think that's it for the lid. So insulation overall, make sure you're getting your right R values. Let's talk about the different materials you have in insulation as well. So insulation, you have fiberglass bats, right? That's the pink, itchy stuff that you'll see in most builder grade homes, right? These are like the starter homes, the homes that are being built, tract homes that are being built 12 on a street at the same time. All the major builders, they like to use this stuff because it's very cheap, very quick and easy to install. So that's kind of your base material for insulation. I tend to do that on all my exterior walls, my floor. I guess that's about it. Anywhere where I need soundproofing as well. So interior walls. It's good for that. It's a good cheap insulation to use for soundproofing. It's also good for exterior walls as long as you have, let's say, like 2x6 framing will fit enough to get the R21 that I need in my area. So I just do 2x6 framing for my exterior walls, and I know I can fit fiberglass bats in there and get the R value that I need. So the next option, I guess, would be mineral wool. This is kind of also a bat style insulation. Where you just cut it with like a bread knife is what I use. I think that's the easiest thing to cut it with. I suppose you could use a few different things. Just like a utility knife works as well. But bread knife is really the easiest in my experience. I've done installations with rock wool, mineral wool installation multiple times. So I'm a little bit familiar with it. I really like it. It's not cheap. Okay. It's an expensive way to insulate generally. I'm trying to find good suppliers that are a little more budget friendly. because there are times where I don't want to go with fiberglass, but it's hard to fit something like rock wool or any mineral wool style insulation into the budget. This is a really good material for doing fireproof homes. If you wrap the exterior of your home with a layer of mineral wool insulation as exterior insulation, which is another, I'll talk about that in a second. I just realized that's another thing that's kind of a newer trend in construction these days that the code is really pushing with some recent changes to the code. But anyways, you can wrap a home with exterior insulation using mineral wool, and that stuff does not burn ever. I mean, you can hold a blowtorch up to it and it's not going to light on fire. So wrapping an entire exterior of a home in mineral wool insulation both gives you great energy efficiency. It's a great way to insulate a home, and it also gives you some fire protection. So if you're in, West Coast, Colorado, any of these fire prone areas, really good thing to put on a house. It is going to be expensive to do, but it's cheaper than replacing a home that burned down. So there is that. Mineral wool, good option. You can use it basically anywhere that you use fiberglass. It's a good option. It's just a higher end option, really. Blown in fiberglass, you can do blown in fiberglass, blown in cellulose. Those are kind of your options for blown in insulation. This is to do blown in, they just net the whole wall. Let's see if I can find it. So this is kind of what we see around our place a lot. They throw this kind of opaque mesh, a fiber mesh fabric material on the wall. They staple it up onto the studs, and then they'll poke a hole in it in each stud bay and fill it with they just use a hose and it blows a bunch of insulation through the hose into the wall. So basically it looks like this when it's done. You'll see every stud bay will have a hole poked in it, and then you'll just see the whole thing looks like a pillow was pumped, or it's like each cavity in the wall turned into a big pillow pumped full of fluffy stuff. Really, really efficient way to insulate a home. Cost effective. It is not expensive like spray foam. It's cheaper than spray foam. It is going to be a little bit more than doing bats, fiberglass bats. I don't remember the exact cost differences. I haven't looked at it in a little while, so I don't know what they are today. But typically in the past, this has been a slightly more expensive option, but it gives you a much better, the bats will leave kind of little air gaps at their edges if it's not installed correctly, or anywhere where you have a seam in the bats or things like that. This just completely fills that cavity and gets you a really nice R value in that wall. So I do like this. It's only slightly more expensive than doing the fiberglass bats. So this is another really good option on spec homes for doing your exterior walls. I don't think there's much else I want to say about that. Oops, I didn't mean to click on that. I just wanted to click back on this window. You can do it for the ceilings as well. The lid works great for that too. So, and this is what you'll see if you have an attic. You go up in your attic, and in between all, the floor joists or bottom cords of the trusses, whatever you have there, you'll see it's like a foot thick and it's fluffy and it's just sitting there on top of the ceiling. That's basically what this is. Blown in cellulose is the most common, and cellulose is just it's like shredded newspaper, kind of is how I would describe it. It's like shredded paper that just packs together really tightly, essentially, and that gives you a nice R value as well. These have very similar R value to fiberglass. So like fiberglass, a 2x6 wall will get you R21. I think with blown in, 2x6 wall gets you R21. So it's essentially the same thing, maybe R22. I'm not positive on that. One thing to be careful of, make sure they don't pack it too tight to where it's bulging out, because if it's bulging out a lot, a little bit is okay, but if it's bulging out a lot and it's like packed really tight, when they go to install the drywall on there, they're going to have problems. So you do want to make sure you have a good installer that knows how much to pack in there, right? You want to get enough to get the R value, but you don't want it to be bulging to where it makes drywall difficult, if you're going to go with this method of insulation. After blown in, you have your spray foams. I already mentioned you have open cell spray foam and closed cell spray foam. Open cell doesn't have as high of an R value per inch, so you're going to need more of it to get the same R value. It's also more porous. It's like a sponge, so it'll soak up it's air. It'll let air through. It'll soak up water, all that sort of stuff. It is cheaper than closed cell. but in my opinion, generally a lower quality product. Oh, and I was gonna mention before, I don't think I did. Be careful about which product you're using where. Okay. I have seen failures in attics because they went in and sprayed open cell spray foam in the eaves. I don't remember all the specifics. I think it was a no, I don't even think they did a cold roof system. I think that's part of the reason it failed. They went in, they sprayed open cell spray foam in the eaves and then up about 4 to 6 feet from the eaves on the roof deck, right? And then all the rest of the house was, I think they did fiberglass or something like that. I can't remember exactly, maybe blown in. But they used some open cell along all the eaves of all the roofs and then up the roof deck for a little bit. I'm not sure why they decided to do that. It's not something that's typically done in my experience. In fact, I don't really know anybody in our area that uses open cell. It's pretty much always closed cell spray foam. But anyways, a year after this brand new home was built, they were having water, like streams of water, literally running down their windows to the back deck. So the back wall of the home had a bunch of these windows on it, and they were seeing streams of water coming down their windows on both the outside and the inside. So they looked into it. They obviously had to tear the walls open. They hired a guy to come out. They did not go back to the original builder because they had other issues with the original builder. So they were not happy with that builder, to say the least. They got another contractor to come out and take a look at what was done. He got me out there as the inspector. We took a look at what was going on with the house. Came up with a list of like 10 different things that were installed wrong. It wasn't just this water issue. Their deck was installed wrong and they didn't get it inspected. That was the main problem. When they built this new home, they went ahead and finished it without getting the deck inspected. Somehow got their CO. I don't remember what exactly happened. I think when they got the final inspection, they said that the deck had already been inspected. At that time, we didn't have a good note system for our planning and zoning. And anyways, somehow it got missed, right? But when the deck finally did get inspected, it turns out that they did some things wrong. They even installed a glue lamp upside down, which, anyways. So yeah, the closed or the open cell spray foam in the attic space had been collecting condensation, I guess, is what the contractor was telling me. Is it looked like, because he couldn't find any leaks, right? But it was collecting condensation. So basically they had sealed up the attic space, and then they didn't do a cold roof system on top of it, right? So this is what I was talking about before, where you can get that condensation on the inside, and it adds up. That that open cell spray foam soaks it up like a sponge. It'll just keep building up till it gets so much water built up in it that it starts leaking down inside the walls of your house. And that's exactly what happened in this case. Huge mess, cost a lot of money to come out and fix it on this 1-year-old home. So be aware of that, using the right product in the right place. If it's a product you're not familiar with or you haven't used before, make sure you're doing your research on it. Installation can really mess things up if you're not doing it correctly. If you're not sure, keep it simple. Just go with a nice, simple vented attic, blown in insulation for your lid, fiberglass bats in the walls and the floor. You're good to go. And then as you get more experience, you can kind of experiment with different things, learn about some new products, and try some new techniques. That would be my advice. Otherwise, plan on doing a lot of research, talking to manufacturers, figuring out what the correct way to use that product is. But yeah, spray foam, just be careful with it. I like closed cell, do the flash and bat system like I mentioned, and it works great as long as you're doing it correctly. Exterior insulation I mentioned as well with the mineral wool. I'll talk about that a little bit more because that is something that code today is moving that direction. Okay. They've basically created, how can I put this? They've created the code in a way where it's going to start forcing people to use exterior insulation unless they just want to start building thicker walls, like 2x8 wall assemblies, because they're requiring higher R values, but they're reducing the required R value inside the wall if you have the exterior insulation, so that the total R value with the exterior insulation and the interior insulation actually comes out to be a little bit less by number value, but because you're wrapping the entire exterior with that exterior insulation, it still meets the requirement, the code requirement. So I'll probably do a live stream or a video or something that goes into more depth on that. because this is more recent changes to the IRC code. Not everybody's familiar with it. Not everybody builds using exterior insulation. It's kind of a newer way of doing things. Not really. I mean, it's been done for a long time, but it's becoming more of a trend lately as the building industry seeks higher efficiency, energy efficiency. So if you're not familiar with it, start learning about it. Exterior insulation is actually a really solid way to build. I believe it's been done for a long time in places like Europe where they build homes to last hundreds of years. Okay. Anyways, look into it if you're not familiar with it. Exterior insulation, it's kind of the future as far as insulating new homes. So you need to know what's going on with it. It's not required in most areas today, though. So you can still get by without it today, and that's fine. There are some special considerations to take when you're doing exterior insulation, like sealing it up from rodents and insects and things, as well as fire retardant, right? If you want to go with mineral wool or just use like a foam board product is kind of like EPS foam board. It was kind of the old school way of doing it. But of course that, you know, if you have a fire, it's just going to melt. Like it's not going to do anything to help. Mineral wool is definitely a better product. It's a little bit more expensive than the foam board though, I think, if I remember right. Yeah, I think that pretty much covers it. Vapor control, we already had the question about vapor control, so I answered that. With the ceiling, kind of goes the same for the walls. As far as vapor control, the way that you need to control the vapor for that home is really going to depend on your climate. So make sure you're building specific to your climate, and there's a lot of really good resources online. Just do a Google search. I mean, it depends on your climate, where you're at, but you can search specifically for vapor control in climate zone such and such, or in this area, right? If you're in Texas, or if you're in New York, or if you're in Colorado, or whatever, search for your area. I live in a very dry climate. It's just naturally very dry. We have almost no humidity for most of the year. So vapor control is not something that a lot of builders in my area even think about. If they're doing a basement, they'll do vapor control barrier in the basement between the concrete and the rest usually, and that's about it. So you don't typically see a whole lot done as far as vapor control with traditional build. New ways of building, the new build science and all that, it's a very big part of it, because it is important to the longevity, the durability of a home, right? Moisture is probably the leading cause to failures in homes. You have to control your moisture, and so a lot of that comes from vapor, which is moisture traveling in the air. So nowadays there's things like Siga Myrex, I think is the name of it. That is a smart vapor barrier, or a retarder, I should say, a vapor retarder. Siga Myrex, right? So it just looks like this, kind of looks like house wrap, honestly. And you're going to put it on the ceiling like I was talking about earlier. This is before you put your drywall on, so you can see a perfect example. It's got a special tape that you use around all the edges and on the seams. You can see him putting that yellow tape on the seam right there. It's also going to go around all the edges and everything. There's different ways, honestly, to install this kind of vapor retarder. When you're framing, you can frame it. You can frame the home with pieces of this put up in between where your partition walls, your interior walls hit the ceiling. So that there's already a layer there, then you just tape it on so that it's a continuous layer through the enveloping the entire interior of the home. That is the ideal way to do it. Then you have kind of the more budget way to do it, where you're just kind of, I don't know if it's really a budget way to do it. I guess I would say the not planned out so well way to do it, where you're going in after everything is framed up, all your interior walls and everything, and you're just covering the exterior walls in the ceiling with this, and you're using more tape, basically. I guess not really. You'd probably use about the same amount of tape now that I think about it. So there's, multiple ways to do it, but this is going to allow, what this smart vapor retarder does, it allows vapor to travel one direction, but not the other. So it would allow, let's say, I think, hopefully I don't mess this up. If it's hot outside, right? So your outside temperature is warmer, you're going to have vapor, I don't know, whatever the temperature is, like if it's cold or hot or whatever, it's going to allow vapor to travel either out or in, depending on which way you don't want the condensation to happen. So if it's colder on the inside and hotter on the other side, then you would risk condensation forming here. So it would allow vapor to go one way and not the other, and vice versa. I probably butchered that, but whatever. You get the idea. It's some kind of scientific material that allows vapor to travel one direction and not the other based on temperature, is what I was trying to say there. I think it's based on temperature, if I remember right. So yeah, that's vapor control is important, but it really depends on your specific area and what is needed for your area. This is a pretty bulletproof way to do it for most areas, though. If you put the Sega Myrex, it's not a cheap product, but if you just want to be extra sure that you have all your vapor concerns taken care of, just cover the entire interior with this, kind of like what you see. Oh, whoops. What you see right here. Exterior wall, ceiling, everything is covered with that Sega Myrex, and you really don't have much to worry about in almost every case I can think of, no matter what your zone is. If you're not doing something like this, then just make sure you're doing what is appropriate for your area, for your climate, right? But this is more or less the bulletproof way to do it. It's just going to cost you more money. Yeah. Okay, let's move on. I got one more phase to cover, or that I want to cover before we finish tonight, and we are already at an hour and a half. So the last thing I wanted to cover, this is going to be phase 13. So we've covered, just to recap real quick, phase 9, mechanical rough-in, phase 10, plumbing rough-in, phase 11, electrical rough-in, phase 12, your insulation, right? And then you have your insulation all inspected. Once your insulation is in, I don't know if I mentioned that, make sure you get it inspected. Most areas, the inspector wants to see that insulation before you cover it up with your drywall or tongue and groove or whatever your finished material is. So definitely make sure you get that inspected. He's just going to check to make sure it meets code requirements, R value, installed correctly, those sort of things. So moving on, now we're gonna get to putting the finished material on the walls. Typically, 80-90% of the time in America these days, it's gonna be drywall. This is very simple, relatively quick material to install for interior wall finish and ceiling finish. Drywall, typically you're gonna have 1/2 inches required for most areas. 5/8 inch is going to be required for some specific areas in the home, basically for fire separation. Okay, 5/8 inch drywall, type X drywall, is going to be a special fire rated drywall, and so it's just rated to last longer in a fire, right? So this is gonna be typically required in places like fire separation walls, maybe the wall between a garage and a home, and definitely on a garage ceiling if you have living space above that garage. So a popular thing to do nowadays is to put like a bonus room or even like a mother-in-law suite or something above the garage. And by all means, I think that's a great idea. Definitely love having the bonus rooms above a garage. Just make sure you're putting that fire rated drywall on the ceiling of the garage underneath that bonus room or that living space up above the garage. The inspector is going to want to see that, and that is required just for safety. So otherwise, 1/2 inch is fine for most of the house. 5/8 is also very common for ceilings, because ceilings are usually framed with trusses that are 24 inch on center, or even rafters that are often 24 inch on center, although those are also common to do 16. But yeah, trusses are almost always 24 inch on center. Or if you have floor trusses, right? Your main floor ceiling, the floor in between your main floor and your top floor is framed with trusses. Then those are going to be 24 on center. Even joists, if you're using like eye joists and those sort of things, a lot of times they're going to be 24 inch on center. So any ceilings where you have 24 inch on center framing, I highly recommend going 5/8 inch drywall. It's just a little bit stiffer. You're not going to notice sagging or anything like that. It's going to hold up better for your ceiling. So I like to always use 5/8 for a ceiling. 1/2 inch is fine for walls. Nowadays, I've noticed a lot of builders have trended towards just doing the entire house with 5/8. I think that's something the drywallers themselves, the subcontractors, kind of prefer, because it makes it simpler for them to order material and to just use that material on site. They're not having to worry about which one they're grabbing. They just keep a stack of 5/8 and they pull for that for everything. Something to think about when you're doing 5/8 drywall for the entire home, though, is going to be like your other door jambs and stuff. You might notice, and it depends on the installation and the materials and stuff, but you might notice door jambs are often made if you're buying pre-hung doors for a 2x4 framing, right? 3.5 inches. If you're going with 5/8 inch drywall, that's adding 1/4 inch to the total thickness of that wall. So a lot of times guys will order door jambs or pre-hung doors specifically for that 5/8 drywall. You can find that, although it's not as common. So if you're just ordering standard, make sure that your installers know that they need to take care of that. There's ways to do that. It's not that hard, because if you center it, you're only getting about 1/8 inch on each side of a gap, and you can usually work with that as far as caulking and everything to make it look just fine. So there are ways around that. Keep that in mind. When it comes to drywall, those are pretty much your options. Sheets are going to be ordered in 8-foot, 10-foot, 12-foot lengths. A lot of times for ceilings, 12-foot is pretty common. Basically, you want to go with the longest span that you can when you're hanging drywall. So if you're ordering the drywall yourself, if the wall is only 8 feet long or less, or the ceiling space going across is only 8 feet or less, get an 8-foot piece. If it's between 8 and 10 feet, get a 10-foot piece. If it's over 10 feet, then you obviously want to go with a 12-foot. You're gonna have your tape, corner bead, those kind of things are also materials that you're gonna need. Mold resistance. There is green drywall. It's like a pale green color. That is mold resistant drywall. Use that in your bathrooms if you're putting drywall as your backer around like your showers, baths. Where else? Really the whole bathroom. If you want to just do the whole bathroom in that mold resistant drywall, that is not a bad idea at all. It's not much more money than standard drywall, so I would recommend that. Although for shower surrounds or bath surrounds, if you're going to be doing tile, you're going to want some sort of tile backer there instead of drywall. I don't like doing tile over drywall. Just use a proper backer board, cement board for that. Let's see, anything else? Screw pattern. So inspection, you're going to need inspection on your drywall when all the drywall is hung before you tape. Okay, before you tape in mud. The inspector is going to want to come and see. He needs to be able to see your screws. He or she needs to be able to see the screws, because they're going to be checking the distance between screws, right? There's a certain screw pattern that will be called out for your drywall. Code calls out a standard pattern, and then if there's something different that's needed, that will often be identified in the plans. But drywall screw patterns are pretty standard, just based on the thickness of the drywall, whether it's 1/2 inch or 5/8, and then where it is, right? Now you're going to typically have something like a 6 to 7 inch spacing between screws around all the edges of the drywall board, or at the seams, right? The edges. And then in the field, what's called in the field, or going across the middle of the sheet of drywall, you'll have it spaced usually about 12 inches apart, 10 to 12 inches. So that's kind of your typical spacing. Ask your inspector if they want to see something different. Check your plans, see if something different is called out. But that's pretty standard. Just make sure they don't miss anywhere. There is also adhesive for drywall. You can do drywall adhesive and basically glue the drywall onto your studs. I'm not a big fan of that. It is handy in certain situations. Typically you just screw it on though. So it's pretty straightforward. The inspector is going to come in and inspect all of that. And then once you've passed your drywall inspection, tell your drywallers to get to town. They'll tape and mud and texture and get it all looking nice, ready for paint. So that pretty much brings us up to where we're going to leave off today. We've made it through 13 phases now of new construction. The only phase that's really left, phase that I break it out into, and phase as far as the inspections that you're getting, is going to be your final inspection phase. So this is where you're getting all the finishes done for the house, going from getting the drywall done all the way up to that final inspection for the CO, for the certificate of occupancy. This is going to be a big phase, so we're going to save this one for next time, and we'll go over this next Sunday for the live stream Q&A at that time. But just give you a quick idea of things that are involved. I'm pretty sure you can think of them. You're going to need flooring. You're going to need all your doors put in, interior doors, all that. You're going to need all your fixtures put in, right? Appliances, that kind of stuff. All your trim needs to be done. You're going to paint. What else? Exterior work like landscape and whatnot. things like that. So we'll go into more detail. Final inspection has a lot of things you need to pay attention to as far as inspection, getting that final inspection passed and getting your CO. Don't make the inspector keep coming back for final inspection. It really annoys me when I have to keep going back to a house for final inspections for a builder who really should know what they're doing by this point, but they want me to tell them what still needs to be done as the inspector, rather than them just go to the house and figure out what still needs to be done. So we'll talk about some of the things that I see most commonly missed at final inspections, and things you need to keep an eye on as you go into that phase. Really appreciate having you guys watch here for the live stream. Anybody that's watching this after as a recording, go ahead and leave questions or comments in the comment section of the video. I do check those, and I will answer any questions I get there as well. These live streams are a big help for me getting information put together, kind of getting my stuff organized and ready to make some more some better quality kind of finished videos for my channel that go over all this stuff. But for now, I think this is a good way to go through it and kind of see what questions people actually have on these topics. So next time we'll get to the all the finish work, the finish phase of the home construction process, and then we'll be done with that, and we'll move on to bigger and better things. Anyways, hope you all are having a great weekend. I hope you have a great week ahead.